Using this, if I want to derive the formula for 1 by 1 plus 6. So if I can write the 1 by 1 minus x as equals to this, then using this I can write the formula for 1 by 1 plus x also, right? So I can also write 1 plus x here as 1 minus x. So if I compare this term with this term, so actually we are just reducing the x term minus x. So this formula becomes 1 minus x plus x, 1 plus x squared minus x.
నీకే వచ్చిందా ఒకటి 10 కోట్లకి మిగతా దగ్గర
minus x to the power n and taking the value from 0 to infinity, right? Okay, so by using 1 by 1 minus x, you have easily derived 1 by 1 plus x. Now similar to that,
విరాట్ కోహ్లీ మాత్రం మేళ 10 కోట్లు 10 కోట్లు వచ్చింది 10 కోట్ల
then now I just have to replace the x term by x, right? So here also you can replace the x term by x. The formula will be 1 plus ax plus ax square. So here also in the summation form also how can I write it? Summation ax to the power n and from 0 to infinity. Okay, so all these formulas are clear. If you are able to remember the formula for 1 by 1 minus x, you can derive the remaining formulas, right? Now the thing is the next formula. The next formula is for 1 by 1 minus x squared. Right? So if you know the formula for 1 by 1 minus x, actually using this formula, you can easily derive the formula for 1 by 1 minus x whole square also. And how you can derive it? So if you see that, can you tell me what will be the differentiation of 1 by 1 minus x with respect to x? Differentiation of 1 by 1 minus x with respect to x. What will be that? Similarly, if I differentiate this with respect to x, and x to the power n minus 1 and
सूर्या मिल जाती है मोमो से
now by using the formula for 1 by 1 minus x whole square, now we are going to see the last formula. So the last formula is for x square 1 minus x whole square. So in 1 by 1 minus x whole square is this. So in the last formula we are just multiplying this by x. So the formula for this will be x plus 2x square plus 3x square. That means this will become summation x to the power n and from 0
నైట్ వస్తుంది
Okay, so now we are going to use these formula for the problems of generating function. The problems that we are going to get a generating function is that we know that whenever any sequence an is given to you, then corresponding to that sequence an, we can write the generating function as g of x is equal to summation an x to the power n. So one type of problem that will be asked to you is, you will be given the sequence an, and using that you have to write the generating function, right? And the second problem will be that you will be given the generating function, and from there you have to derive the sequence an. So these are the two types of problems. Given the sequence an, then how can you derive the generating function? So this we are going to see in the first problem, problem number 2. Okay, so write down the statement for problem 2. Okay, write down. Define generating function. Question is define generating function of a sequence. Define generating function of a sequence and iterate with example. And illustrate with example. Next line. Determine the generating function. Determine the generating function for the sequence. Determine the generating function for the sequence. So the first sequence is given to you as 3, sequence of 3. Second one is sequence of n plus 1. Then next part is sequence of n to the power n. And last part is sequence of a to the power n. So in this problem, function with example. Okay, so definition and example we already taken, so that you can use it. Now, in all the 4 parts, you are even given with a sequence, and corresponding to that, now you have to find out the generating function. So in the first part, we have been given the sequence of 3. That means in the first part, we are given that a value is 3, right? So if a value is 3, then in that case the generating function g of x will be. So if a is 3, so by definition gx is summation a x to the power n, right? So if a value is, you can put that a value here. So gx will be equal to summation px to the power n from 0 to infinity. Right? Now the thing is, whenever you have to find out the generating function, so because generating function is a function of x only, so in that case you can't write the generating function like this, because this function is a function of x also and it is a function of n also. So when you are writing the generating function, don't leave the generating function in the summation form. In that case, what you can do? In that case, you can use any of the suitable formulas. So when you have this summation px to the power n, and now if I take p outside the summation, right? 3 if I take common, so this will be p into summation x to the power n. Now can you tell me for summation x to the power n, which formula we have done? You can also write it as 1 minus x. So that means if I put that value here, so finally g of x would be equal to 3 divided by 1 by 1 minus 6. So this is the generating function, right? So whenever you have to find out the generating function, don't leave that expression in the summation form. Always write it in terms of x. Okay, now first part is easy. Right? Likewise, we can do the remaining parts here. Okay, so in the second part, we have been given the sequence of n plus 1. So that means we are given a n value as n plus 1. We have to find out the generating function. Summation a n or n. So if I put a n as n plus 1 now, this will be summation n plus 1 x to the power n. Now we have to use some formula here. But we don't have any formula for summation n plus 1 x to the power n. Right? So what we can do here, you can separate these terms. You can write it as summation nx to the power n plus summation x to the power n. Now summation nx to the power n. So the formula for this is x square 1 minus x square. And what is the formula for this? Yes, first formula 1 by 1 minus x. Now here you can take the LCM. Okay, so if I take the LCM here, so now the denominator will be 1 minus x whole square. So now if I take the LCM, so this term will be as x and plus 1 minus x. Right, so x will get cancelled out. So finally 0 of x will be equal to 1 minus x whole square. So actually, whenever a n is given to you, you can easily find out the generating function from this, right? Okay, now I will solve that third part for you. Similarly, you can solve the fourth part. So if I see the third part, in third part what is a n value? So a n value is 2 to the power n. That means g of x will be summation a n value equal to here. This will be summation 2 to the power n x to the power n. So now 2 to the power n x to the power n, I can also write it as 2x to the power n. And just now we have done the formula for summation ax to the power n. So if I put a is equals to 2 here, so then I can also write this as, so this you can also write it as 1 by 1 minus 2x. Okay, so this is the generating function. So if for 2 to the power n we are getting the generating function as 1 by 1 minus 2x. So what will be the generating function for e to the power n? 1 by 1 minus 2x. For the last part, generating function will be 1 by 1 minus x. Okay, understood. So actually going from when a n is given to you, then finding out the generating function is easy, right? But the main thing comes when generating function is given to you, then you have to derive the a n from there. So the next problem, problem number 13, is actually that type of problem where you will be given the g of x value and you have to derive the sequence. Okay, so you can first write down the statement for this problem 13. Determine the closed form expression sequence AN of the sequence AN. Determine the closed form expression of the sequence AN whose generating function is so the first generating function is g of x is equal to x by 1 minus 2x into 1 plus 3x. Second part is x by 1 minus x into 1 plus 6. In the second part, please make this change here. This is a small mistake. Instead of x plus 1, the numerator is x. It's not x plus 1, it is x. Why? Because if this would have been x plus 1, then these terms would have cancelled out. These the numerator is x. And the last part is g of x is equal to 1 by 1 minus px into 1 minus px. Please, whenever this type of problem is given to you, you have been given with the g of x. So in all these three parts, g of x is given to you, and you need to derive the closed form expression of a. Right? So do you remember we have done the general form and closed form? Yes. So what was the general form? And what was the closed form expression? Do you remember? Okay, general form is when you can write the electron A in terms of its previous term. So when you can write A in terms of A minus 1, A minus 2 up to A now, that type of expression is the general form. Right? And what is the closed form? When you can write the nth term in terms of natural number n. Right? Like if you can write A is equal to n plus 1. So in this case, we are writing the nth term directly in terms of n. Okay, we are not using the previous terms. So this type of expression is the closed form. So actually in the 12th problem, all these parts that have been given to you, these are actually the closed form. Right? So actually, whenever closed form expression is given to you, then from there we have derived the generating function. So likewise, using the generating function, now we have to derive these type of closed form expression. Now you might take the first part. So in the first part, g of x is x by 1 minus 2x into 1 plus 3x. So the idea is that just now we have done one formula. In the standard formulas, one formula we have done for 1 by 1 minus ax. Right? So it is summation a to the power n. Yes. So for 1 by 1 minus ax, this is the formula. So the idea here is because by 1 plus 3x, where a and b are the constant terms. So if I can write this expression in this manner, so now once you have written this, then in the first term I can use the formula of 1 by 1 minus 2x. Yes. And in the second term I will use the formula of 1 by 1 plus 3x. So for both the terms I can use this formula. Right? So this is the idea. So if I have to yes, method of partial fraction. We can write this expression in this form by using the method of partial fraction. Okay, so the idea is if I want to write this g of x in this form, so I have to find out the values of a and b. Now in order to find out the ab values, I just have to compare this side and this side. Now this side is already there, this you can keep as it. Now you can solve this right hand side. So in this right hand side, first you can take the LCM. So if I take the LCM here, so this expression will be a into 1 plus 3x plus b into 1 minus 2x divided by 1 minus 2x into 1 plus 3x. So now this is your left hand side and this is your right hand side. So now if I compare both the sides, so can I cancel out the denominator? Yes. So now you can cancel out the denominator here. And now you can compare the numerator. So numerator will be same. So now I can say that this x will be equal to a into 1 plus 3x plus b into 1 minus 2x. Now by comparing both the sides, left hand side and right hand side, I need to find out the AB value. Now this term, I can also write this term like this. So because in the right hand side you have x term also and in the constant term also. So you can group together the x term and you can group together the constant terms. So you can combine the terms with x value. So first of all, if I take x common, so I can take x common from P and I can take x common from here also, so minus 2b. This will be one term. So the idea is because I can write the right hand side down as some constant term into x plus constant term. So this type of expression if I write it on the left hand side also, then I can compare both the sides. So x also in the same manner. Constant into x plus constant. So how can I write this x value? So I can write it as 1 into x plus 0. So x we can write it as 1 into x plus 0. Now you can compare both sides. So first you can compare the coefficient of x. So I can say that 3a minus 2b will be equal to 1. And then you can compare the constant terms. A plus b will be equal to 0. So by comparing, we can say that 3 minus 2b will be 1. And a plus b will be 0. Now you can solve this equation to find out the AB value. So let's say this is your equation 1 and this is your equation 2. So you can from second equation I can say that b equals to minus a or a equals to minus b. So if I take the second equation b will be minus a, you can put that value in first equation. So if I put it in first, so now I can write first equation as 3a and b value is minus 6, so this will be plus 2a equals to 1. So 5a will be 1. So a will be 1 by 5. And if a value is 1 by 5, so b value will be minus 1 by 5. Now once you have calculated the AB value, now you can put this AB value here. So put this AB value here. So now I can write this g of x as. So if I put the AB value, so now g of x would be equal to a divided by. So a value is 1 by 5 now. So 1 by 5 divided by 1 minus 2x and b value is minus 1 by 5 divided by 1 plus 3x. Understood? Okay, so now once you have separated the terms, now individually you can use that formula for 1 by 1 minus 3x. So you of 1 by 1 minus 3x, so 1 by right? 1 by 5 will be as it is. Now how can I write 1 by 1 minus 2x? So 1 by 1 minus 2x will be summation 2x to the power. Now similarly 1 by 5 is there. Now how can I write 1 by 1 plus 3x? So now because 1 plus 3x